Welcome back to our RPG tutorial series. In this episode, we are finally making our health and experience bars do more than just look nice. We will introduce healing with mushrooms and add new player stats that have a real impact on the gameplay. So this is a big step toward turning our project into a proper RPG system instead of just a very ambitious experiment. Let's get started. We finally move on to the code. This time, we create a new script, but without a scene attached to it. We'll call it player stats. This will be the new place where we store all of our character values and stats. For that, we change the script type to a resource. We give it the correct name, and then we start adding all the variables we're going to need. Stay with me here. I'll quickly list them all. You can just copy them for now, and then we'll continue together afterward. And this is also a really good moment to show the best way to define variables properly. We use export so the variables show up in the inspector where we can view and edit them easily. And to keep things safe and clean, it's best to define each variable with its type as well, using a colon. So for example, int, string or float. That way, the script knows exactly what kind of value to expect, and we avoid unnecessary chaos later. We'll also need a function for this variable here, the required experience for a level up. We'll build that function together later. For now, we'll just define it here first, and continue listing the rest of the stats we need. In addition to these variables, we'll also need a few core functions for this system. First, we need gain experience. This function will be called directly by the enemy and will send the amount of experience the player should receive. Next, we'll need a level up function that handles everything when the player reaches a new level. And finally, we also want to save all this data. Right now we do have a basic save system in the project, but it's still quite limited. So we're going to build a new and improved save system, one that allows us to store all of our character stats properly. Now let's build the function that calculates the required experience for the next level. For this, we'll use a mathematical formula, so the required experience automatically scales with the level. First, we round the final value, and then we raise the player level to the power of 1.8. I'll show you in a moment what this looks like on a graph once the formula is applied. After that, we also add the player level and multiply it by a scaling factor. This gives us a smooth curve for how much experience is required per level. On this graph, you can see how the required experience increases as the level goes up. Thanks to this formula, higher levels automatically require more experience to level up. For example, at level 1, you only need around 50 or 60 experience points, but by level 22 or 23, you already need around 400 experience points for the next level. This kind of scaling is very common in most RPGs. Of course, you can always tweak the values to change the progression curve, but this setup works quite well as a solid starting point. Now let's move on to the next function. This one is triggered directly when an enemy dies and awards the player a certain amount of experience points. First, we add that value to the total experience. Then we also add it to the current experience, which is tracked per level. Now comes an important part. We run a check as long as the player's experience is greater than the required experience. This is important for cases where the player receives a large amount of XP. For example, after completing a big quest, the player might earn enough experience to gain 2 levels at once. So during this loop, we subtract the required experience and call the level up function. This process continues as long as enough experience remains. Now let's look at level up. Here we simply increase the player level by 1 and then update the required experience value. We do that by calling the function that calculates the required experience for the new level. As mentioned earlier, we'll also need to rework our save system. The reason is simple. We're now working with a new resource and we also have many more stats to store. So in this script, we list all of our variables like this. This function will later be called from another script. When that happens, we pass in the current values of all the variables and then we simply store them here inside this resource. Now we need to save this script properly. First, we create a new folder for our resources, so we also have a place for any future ones. Inside that folder, we create a new resource. Then we simply enter the name PlayerStats class and create it. Now the resource is saved as its own file. All of our variables are already predefined inside it. And the nice thing is, we can even view and edit them directly in the inspector. Next, we need a script for our player UI. We create it here on the control node and save it as usual inside our scripts folder. Now we'll define variables for the interactive nodes, like our labels and the progress bars. We'll do this using onReady variables, so they are initialized as soon as the node is ready. This makes the code much cleaner, because the node paths can get quite long otherwise. By storing them in variables, we keep everything more readable and organized. I'll quickly list all of them here and speed up the video a little bit while doing it. Now inside our process function, we continuously update all the UI elements. Let's start with the health bar. First, we set the max value, which represents the player's maximum health. We retrieve this value from our global script. However, the variables inside our global script are not up to date yet. So first, we remove these old variables since they are now stored inside our player stats resource. Instead, we load our player stats class directly into the global script. Here we just need to provide the correct path to the resource. Once that's done, all variables stored inside player stats become accessible through this global variable. Now I'll show you how we access them. Back in our UI script, we reference them like this. First global, then player stats, and then the specific variable we want to access. I'll quickly copy it here just to avoid any typos, and that should work. Now we repeat the same process for the other values. Next is the current health, which controls the value of our health bar. Then we also update the regeneration health bar. For that one, we again need the max value and the current value. I'll copy the names again to make sure everything stays correct. And now we simply list all the variables we need for our player UI. So far we've been changing values directly, but for the mushroom chunks, we now need to update the text of a label instead. So when we access the label, we want to modify the text field. If you hover over the property here, the editor actually shows you the exact property name and how it can be accessed through code. This is a really useful trick. You can do this with almost any property to quickly figure out which command you need in your script. In this case, the property we need is simply text, so we just assign our value to the text property of the label. Alright, that's it for our variables for now. As you can see, we're using different properties here. For example, we use max_value for the progress bars and text for the labels. Now let's talk about saving the data. Previously we used a file management resource for our save system. We won't need that anymore. So first we close it, then we go into the script and remove it completely. Now our save system was still referencing that file, so we need to update it to use our new resource instead. When starting a new game, we simply load the player stats resource. And here we can actually simplify the code a bit and make it cleaner. When the player saves the game, we set this variable to true, so the game knows that a save file already exists. Now, when loading the game, we first create a local variable that stores the loaded player stats. Then we pass these values to the global script using the function apply_save_data. This step is very important. It creates the bridge between the save data and our global player stats system. Without this step, the player stats functions wouldn't receive the correct values. And if no save file exists, we simply start a new game. Now let's take a look at the preload step. Here we check whether a save file already exists, and just to be safe, we also set the save variable to true if one is found. Alright, let's test it. There's a small issue here. Earlier I mentioned that our labels display the item amounts, but the label text property expects a string value. Right now, our variables are still defined as integers, so we simply convert them into strings before signing them to the label text, and that fixes the problem. Alright, let's run another test. Good, the UI is working properly now, but we've got another error here. Right, the issue is simple. We never actually defined the player strength, so let's jump back into our player stats. Here we'll add a few new variables. First, we create stat points. We'll use these later to distribute points into different player stats. For now, we'll only add strength. Later on, we'll expand the system with additional stats. Of course, we also need to make sure that this variable is loaded from the correct place. and it looks like I'll need to go through the script once more and update all references so they point to the new location of our variables. Let me quickly apply all the necessary changes. Another issue we're seeing right now is that the knockback doesn't really work properly. Another error, this turns out to be a player stats issue. The problem is actually quite simple. The player's strength value is just too low. So for now, we'll simply increase it a little. Later on, we'll handle this more properly using a formula. Now we can at least see a small knockback effect. We'll definitely increase that later. And there's another player stats error. At this point, I think I'll quickly search through the script and fix all the remaining references to the new player stat system. Alright, at least I found one more error. It wasn't really affecting the game, but it would have caused a problem here as well, so I think that should be all of them now. Honestly, I actually like the knockback at this point, but I can already see that the essence values are not being added correctly. So right now, experience works, the experience bar works, the mushroom chunks work, but essences are still not working, and the health system also isn't working properly yet. We'll need to fix both of those next, and we also still have to test the level up system properly. So for the level up test, we'll simply boost the amount of experience we gain and see if everything works correctly. Alright, first we'll add essence drops for the player. We do that right here. This is where the death timer finishes, which adds a small delay before the player receives the experience and the essences. Both rewards are granted at the same point. Next, we'll increase the experience gained per enemy. For now, we simply add a value here. Instead of a small amount, we'll send 50 experience points through this function. Now let's move to the player script. Here we can remove the old health bar, since we now have our new UI system. Next, we need to update the health display. For the current health, we subtract 20 points each time the player takes damage. Then we also update the regeneration bar, the yellow one. For that bar, we subtract 10 points. And yes, this also means we no longer need the update health function, so we can delete it completely. And of course, we also removed the place where it was being called. Alright, let's test again. Good, the health bar works. We're receiving more experience, the essences are being collected, very nice. The level up system works. but now the death system doesn't trigger anymore. So let's take a look at what's going on there. Alright, now let's fix the player death system. Inside this function, we simply need to switch to the global variables. Just a small correction. The player alive variable can stay exactly as it is. And while we're here, we'll also implement the automatic regeneration. For this, we again use the global variables and slightly adjust the logic. So instead of checking whether the health is below 100, we check whether it is below the regeneration limit. If that's the case, the player regenerates 5 health per tick. I don't remember exactly what we set for the timer, probably 1 second. Next we add a safety check. If the health rises above the regeneration limit, we clamp it back to that limit. And if the health ever drops below 0, we also clamp it to 0. Alright, let's test it. The damage works. And the regeneration works as well. The healing now correctly stops at the end of the orange bar. Perfect. Next we'll add manual healing using the mushroom chunks that the player collects. So let's implement that next. Now let's add the healing system. For this we'll create 2 functions. One for the actual healing and one for a flash heal effect. The flash heal will work just like the flash hit, just in green instead of red. So we can simply take the existing function, copy it and paste it. And since the sprite here still has the same name, we can reuse it without changing much. We only need to switch the color. This time the sprite should flash green for 0.1 seconds. Next, we need a new input action for healing. Then we go into the project settings and assign a key for it. Since we named it healing, we'll bind it to the H key. But of course, we also need to check if we actually have mushrooms in the inventory. And if that's true, we subtract 1 mushroom chunk. Now we also need some logic for the regeneration limit and the current health. When the player eats a mushroom, the current health should be set equal to the regeneration limit. That way, we instantly refill that regeneration gap and also gain 5 extra health. At the same time, the regeneration limit must never go above the player's maximum health. Then we add the flash heal function, call the healing function inside the physics process, and test everything. Alright, we use the mushroom, the regeneration limit fills up, but something still isn't right. The regeneration limit should actually increase by 5 points each time. Let's take a quick look. Okay. Yeah, I think I see it. We forgot to use the maximum health value here. That needs to be changed. And the logic is also slightly wrong. We want this to happen as long as the health limit is still below the maximum health. Let's test it again. And there we go. Now it works the way it should. Very nice. Of course, we also need to test the save system. This is a very important part. So first, we collect a bunch of essences, then we trigger a level up, and finally we save the game. Now let's check if all the values are stored correctly. Alright, the level is saved, the essences are saved, and the mushrooms are saved. But there's one thing I'm not happy with. The regeneration bar resets to 100, so the current health was saved correctly, but the regeneration value wasn't. Let's take a look at what's missing. First of all, this health variable here is no longer needed. And looking at the save data, it's pretty clear what the issue is. The regeneration value is completely missing, so we need to add that variable to our save data as well. And with that, we're finally done with our health bar, the experience bar, and the level system. So, what do you think about the result? Let me know in the comments. If you have ideas or think there are important features that we might have missed, feel free to share them. Maybe we can include them in a future update. Next, we'll start adding the remaining player stats that the character gains when leveling up. For that, we need a few new variables. We'll add Constitution, Agility, and Perception. Yes, I think that covers the core ones for now. And of course, we'll also include these stats in our save system so they're stored properly. I'll speed up the video here while I add all the variables. Now that we've added these new variables to the resource, we need to save it again. The easiest way is simply to overwrite the existing resource. So we create a new resource with the same name. As you can see, all the required stats are already there and the resource is still stored in the same location. Now let's go back to our knockback system because the player's strength directly affects it. Since our strength values are currently quite small, we need to add a multiplier to the formula to get a noticeable knockback effect. Let's try a value of 300 first. Alright, that's actually a bit too strong. The enemy gets pushed all the way out of the aggro range. So let's reduce it to 200 instead. And that already looks much better. Of course, this simple formula won't scale perfectly for higher levels, but I'll leave that tuning up to you if you want to refine it further. And with that, our health and experience systems are now fully working, healing is in place, and our stats finally affect the gameplay. So the project is starting to feel even more like a real RPG. Thanks for watching, and I will see you in episode 11.